Bruce, stop ignoring me. You do not need to guard the biscuit tin. The biscuits are safe. I promise you, they're fine. Hello everybody, welcome to my kitchen again for some more marvellous maths. And this week we're going to be using this book by Oliver Jeffers, Lost and Found, as the springboard for our work. Particularly the words lost and found, because this week we're going to be thinking about missing numbers. And in particular missing numbers in word problems. Now I've gone for a bit of a nautical theme here, or a seaside theme, and I've written a question or a problem here. Okay. There are 50 seashells in the rock pool, and after the tide has been in and out, there are 32. How many were washed away? Now there's an awful lot of words there, and that can sometimes be a bit confusing and make us sort of think, oh, I can't do this, it's too complicated. But actually it's not. And that's why I've put rings, or you could underline, the really important information. The seashells aren't so important, and the rock pools and the tide, that's not the important thing. The important is there were 50. Now there are 32, so straight away I know that's subtraction because the number is getting smaller. There were 50 and now there's 32. How many were washed away? And that's my missing number. Now I can use bar method to help me understand this problem a little bit better. Okay, there it is. Now I'm going to write the 50 in the top, because that's how many there were all together. That was the total, really. There you go, at the top. And then I know that that 50 has been split into two. So I know that there are 32 left. I don't know how many were washed away. That's the missing number. Now, I know that if I add those two numbers together, it will total there. So even though it's a subtraction problem, I can use my inverse operations to help me do this. Okay. As well as, of course, my trusted empty number line. Okay. So, first of all, I'm going to write the 50 there and the 32 there, because that's how it would look on a number line. There was a number line with lots of numbers, like a ruler, it would look like that. But this bit here, that's the missing bit. That's the bit we don't know. We want to know what that was. There were 50, now there are 32. How many were washed away? Now, this is where we have to use some of those skills that we've been learning. We know that it's easier if the numbers are multiples of 10. We know that's easier to work from. So let's see if we can add on to this to make the next multiple of 10, which will be 40. What do I have to add to 2 to get it to 40? Well, number facts, we should be learning these, so we know that's going to be 8. I've got 32, and I add 8 more, it will make 40. I know that the difference between 40 and 50 is 10. Okay, what's the missing number in the middle? Well, I could do 8 and 10, but it's easy to do 10 and 8. And the answer in here is going to be 18. There you go, it made something that looked complicated and tricky and something that wasn't really complicated or tricky, and use lots of the things that we know. Have a go. You can make up your own word problems. You could send them through to me for me to solve. Have a go at trying them yourself and use the bar method to help you understand, and the empty number line to work it out. Now I've got another job for us. There are a few on the website, but I'm just going to show you one more. We're going to be thinking about pyramid numbers. Now we did this in the morning as a sort of a challenge for a while. So actually this is not unfamiliar to you. Mums and dads and carers, watch out. Sometimes these pyramids are tricky to draw. Okay, you've got to have the overlaps. They're really important because these two numbers are going to make the total for this brick, and then that number and that number are going to make the total for this brick here. Really important they overlap, otherwise it's tricky. Please do not, hang on, I've got one here, do a pyramid like this, because these are not addition pyramids. Okay, if you do an addition pyramid, you can go for something a bit bigger. But these are multiplication pyramids. Whoa! You've been learning all those multiplication facts. Let's have a go at using them. Okay? So, let me choose a pen. That one will do. So, I've got 5 times 4. Now, that's tricky, but I can swap them round. We talked about that, inverse operation. So, I can make that 4 times 5. Whichever way is easier for you. And the answer to that is going to be 20. Okay. Now I've got to do this one here. 4 times 1. 4 times 1 is going to be 4. Okay. Right, now I've got to times these two. 20 times 4. Well, if I take away that 0, it's a bit like saying 2 times 4 or 4 times 2, okay, which is 8. Add the 0 back on again. I've got 80. Don't make these numbers too high to start with, because otherwise you're going to end up with a number very big up here, which is why I don't do those huge pyramids. I tried one, it got complicated. Now what you can do is give yourself a little bit of challenge. Now we did a 5, a 4 and a 1. I wonder if I arrange those numbers at the bottom, whether I'd come out with a different total. So you could do a 4, a 1 and a 5. Okay? I could have done a 1, a 5 and a 4. To find out which order makes the biggest total. Is it always better if the larger number goes first? Is it better if the smaller number goes first? I don't know. Try it out. Have a play, have an experiment with these missing numbers. Well, Bruce and I are going to go for a little now. So we're going to say bye-bye and have lots of fun. Send me your work. I love to see it. Take care, everybody.